requirement change. Okay? Certainly does not give reward to requirement change. But here, in the agile processes, more adaptive, you actually give credit for people to incorporate fixes and new requirement items. If you give people credit for it, basically you pay people accordingly for their effort in maintenance and adding new features. Certainly they will be less frustrated because they got paid, right? And also another thing is frequent change can have adverse effect on maintainability of the product. How do you guard against this? You're probably tired of me saying this, but regression test suite, okay, is our last line of defense against those adverse effects from making changes to it all the time. Okay, and also another weapon we have is basically by refactoring. So basically, you're rewriting your software system. Okay, so what is refactoring? For instance, if we have gone through 3 sprints, taken care of 20 requirement items, okay? For first sprint, we did 7. Second sprint, we did 7. The third sprint, we did 6, okay? Remember, for the first sprint, we only considered the first 7 requirement items when we set up the system architecture. Then in the second sprint, we add another 7 without changing the architecture. So who knows whether the original architecture is a good fit for the 14 or not, right? Then the third sprint, we add 6 more features without changing the system architecture, basically by patching it up with more code. 20 features. Well, the system is only designed for the first 7. You know the architecture is not going to hold. More likely than not. Now, what is a refactor sprint? Basically, we're going to spend next sprint re-architect our system and rewrite our code. As now we know the 20 features and come up with the best architecture for those 20 features. Re-architect our code, rewrite our code so that it will actually be the best architecture, best code we can have within our time, 4 sprints for these 20 features. Okay? Then, essentially, we improve the quality of our code, and we also improved architecture of our code. And this is the time we can apply our regression test suite to make sure that we have taken care of all the features we have implemented in the first 3 sprints are still there, still working, while we improved the architecture and maintainability. This is called refactoring and auto-refactoring sprint. Now you have a system architecture well suited for the 20 features. You may have another sprint which is adding 7 more features. I mean, maybe another one, you're out of whack again. Then you go back for another refactoring sprint. Why we do that? Because now, as you have already implemented all the features, you know them now. You know they're in and out of what they are doing. So you can actually pick the best architecture for them. Okay? Before you implement all these features, you don't even know these features. I mean, the likelihood you'll pick the best architecture is close to 0. Okay? Refactoring is very important if you have frequent changes and maintenance requirements. Right? So in practice, I mean, your client typically will say, yeah, I need this change. If you still want that customer, basically you have to go make the change. Right? Essentially, the customer holds the key, right? This is not something say you have a material that they have to use. No matter what kind of thing you provide, they will take it. No, they can go to other places, right? So if you don't provide the service and software system they need, they will take their business somewhere else. You lost. So pretty much, this moving target problem is a good problem now. In essence, if they don't have new requirement for you, you know that you are actually in the real trouble. Okay? There's nothing called a software project is done. The software project is done only when it's dead. Okay? Any software project that's meaningful today is an ongoing project for years to come. If it's not evolving anymore, I suggest you find a different job. Okay? If your system is stabilizing, your system you're working on is stabilizing, no new customers, that's an indication of, okay, this project is getting old. All right? You may consider a different job. Okay, so certainly there are no use to implement the change slowly. The relevant personnel can be replaced. So essentially, if you have certainly, if you are not in charge and your manager wants to change, you have to change it. Your customer wants to change, you have to change it, right? The change is constant in our industry. So this is not in medical profession. The human body hasn't evolved in thousands of years. Okay? The medical techniques evolved slowly, probably in a lifetime. Okay? Our industry is not that kind of industry. Okay? The thing you study today in class is already obsolete. Okay? So the only thing you learn is the ability to learn. Okay? To be honest, the only thing you learn while you are in university is the ability to learn new things in our discipline. Okay? All the things that we teach you here is that you can learn new techniques and new things to do a new job. Okay? It's not about, okay, how to program the chat app. That wouldn't give you a job. That may give you a first job, maybe, but not going to last. Okay? Here, basically, you have to learn new things every day. For instance, if you don't know some basics about machine learning, you're at a huge disadvantage today. This is definitely not a requirement 10 years ago. Okay? Because the current application or techniques for machine learning, tools for machine learning, only appeared in the last 10 years or even less. But it's significant. If you say, oh, I don't want to learn it, good luck with your next job, right? Okay, let's see, in terms of object-oriented software, what do we need to be concerned about it? In terms of maintenance, the product consists of independent unit objects, right? Encapsulation is good. Conceptual independence, when you basically basically put the data you want to keep and the method of operations on these data in the same place. Information hiding, you can't access my data unless you go through my interface, right? Message passing model, right? Although message passing may be implemented through method call, calling your interface method, but it's actually abstraction in message passing. I'm sending you a message. Basically that I'm calling your method, okay? So these are good features which helps maintenance, but there are also some practical difficulties we have to deal with, right? The inheritance hierarchy can be complex, and we also have polymorphism and dynamic binding, which can be your enemy. Your friends in programming is going to be your nightmare in validation and testing. Okay? So as we create more syntactic sugar to make our programming life a little bit easier, we might have make our validation and testing life much difficult. Okay, so overall, would would the benefit overcome the downside? You have to look at the particular project. Overall, it is, but there may be projects that this actually causes more harm than good. For instance, I mean, inheritance hierarchy can be fairly deep. You're from undirected tree to directed tree to rooted tree to binary tree, and all these good things, right? Now you actually say, oh, I'm going to call a particular method with this deep hierarchy, polymorphism, and dynamic binding. Okay, when you call a method, you don't even know which version of method you call. Okay, this happened to all of us, right? We modify the code and say, oh, this should fix my bug. Guess what? Nothing changes. The bug is still a bug. My program still crash, still behave badly. Why? Because you are modifying in the wrong place, right? So this actually will happen a lot in your object-oriented programming environment, because you actually have a deep hierarchy, inheritance hierarchy, and overloading, which are causing problems. Okay? You can flatten the hierarchy, but I mean, there is a disconnect between the flattened one and the original one. And also, polymorphism and dynamic binding, you really need to figure out which function got called, right? First, you have to trace and find which function you call. Otherwise, as I mentioned, you may be fixing the wrong places. Yeah, when you this should take care of my bug. No, it's still there, because you actually modified the wrong implementation. Okay, polymorphism and dynamic binding, very good programming concept. Based on them, you can create a lot of nice tricks in terms of programming, but debugging them could be a nightmare if you don't fully understand what's going on. Okay. As you add more level of abstraction, also syntactic sugar to make your programming easier, do keep in mind, this may actually make your debugging and validation much harder. Okay, because you are more detached from the reality. Okay? So more level of, so for instance, if you are using a machine learning system, if something is not working, it could be very tricky to debug. You don't know if your machine learning system is wrong, or your model is wrong, the data is biased, or the execution environment is wrong. Anything can go wrong, because you are sitting on the top of the food chain. If there's a bug in the runtime system, okay, it's masked by all these layers. Debugging this could be a real problem. Unlike our chat app, you may hate the chat app by now, I'm sure. But one nice thing about it is you have full control about every line of code, because it really requires minimum library utilization. Guess what? That is actually what makes your debugging much simpler than when you sit on top of a complex framework. Okay? When you utilize a complex framework, debugging can be a real problem. Okay? The reason we developed this particular project is actually to make it complex enough. At the same time, you have full control about that code. So you have nobody else to blame but yourself. Okay, if it's not working, you can. If you come to me and say, "Oh, I think Java socket library is not working," I'm not going to believe you, right? But if we give you a complex machine learning framework, although I may be saying probably you're wrong, but I may be in the back of my mind, I'm thinking, wow, this could be a bug in the system. Okay, but in our case, it's not going to be. Okay. So this is definitely, they're very helpful in terms of development because the concept is really neat, right? Overloading, polymorphism, and so forth, really neat. But really, once you get to debugging, it actually muddy the water. You can't really see the real implementation. And actually, sometimes we have to go down to the binary code and see what's going on. The consequence of inheritance also is a problem, right? We create a new subclass where inheritance, the subclass does not affect any superclass, does not affect any other other subclass. If you modify the subclass, no effect on other classes. However, if you modify the parent, that is going to be a problem. Okay? Once you have a deep inheritance hierarchy, if you modify a parent superclass, wow, you may be creating a lot of trouble. Okay? This is when you break the system, break the whole build. Your private copy, your baseline is there to save you. Okay? You go and say, oh, I found a bug in the parent class. Great, I'm going in and fix it. Then I'm happily checking into the main branch. Guess what? This will break a lot of things. And your private branch, if you have debugged this in your private copy, regression test suite, not infringing on the previous baseline by using GitHub, your life is safe. Otherwise, your manager will be on your neck all day. Okay? So that's why Git is there to save you. Okay? If you're not using Git, that's not good. Okay? To address this problem, to keep this bug from propagating, private copy and baseline is the difference. Okay? If you modify this is like you modify the root library. Okay? This is, you're going to break a lot of things. Yeah, whenever somebody change Linux API, come on, all the modules will break. Okay? That's the time when all the Linux kernel programmer was scratching their head and see what's going on. Right? Why are you changing this again? Although they change it all the time, right? So that is when everybody has to spend some quality time with the new kernel API. All right, inheritance also good in terms of development concept, really neat, tree-based structure, the beloved data structure we all like, right? Easy to understand. However, once you come to debug time, it creates a lot of mess. All right? Because first of all, you need to locate where exactly is the bug. If it's happened to be in a superclass, okay, this is not in your control only. Okay? For instance, the three of you are working on a project, and now all three of you actually inherit from the same class. And now you found a bug in the superclass, you have to go fix it. These two guys are watching you, really, because they will be concerned, right? What you are changing very much could break their own module, okay? Then these guys are the guys who are going to sit on you in the review process and refusing to give you the okay to check in your code, all right? So this is actually how the process should play. So that this will keep you from break everybody's code. Okay? You work on that, you private copy, you send the patch, send the change to your colleague for review. Only when you got their okay, now you can push it to another branch. So in terms of the skill set, essentially for maintenance, you should be able to determine the cause of failure of a large product. Also needed during integration product testing. All right. So this is something you have to keep in mind. Working on a class project in your classes are far different from what you're going to work on in real job. Here, our project, 1,000 line of Java code, max, right? Yeah, you probably know every line of code. Once you get to your job, your manager say, here you go, the repository, once you check out, you did a quick count, 50,000 line of code. Okay, wow, this is going to be trouble, right? Suddenly, you're making the jump from 1,000 line of code to 50,000 line of code. All right? So this is actually one of the biggest hurdles which will keep you from becoming a real programmer. Whenever you see 5,000 line of code, you faint. Right? Because I only worked on 500 line of code before, now I have to deal with 50,000 line of code. Okay? So the ability to comprehend